We're going to quickly discuss the tangent problem. One question that motivated the development of calculus was a geometry problem, and it was called the tangent problem. And basically, they want to see what point, if this line intersects at one point on the circle, and this would be called the tangent line here. So I'm going to signify the tangent line is line and then T for tangent line. All right. So basically that's what it means. And the tangent line to the graph of F contains the one point. And what we're going to use is a curve. We'll use the curve of a graph. And I'd like you to recall in pre-cal, you should have done the equation of the secant line. I do have a video on that. But for example, the green here is the equation of this is the secant line here. Now, if you keep moving the secant line down, and then move it to say here and draw it here, and you can keep constantly moving this line down, eventually you'll get to the tangent line where it hits at only one point here. The secant line hits at 2 points if it's on a curve. So you already remember the slope of a secant line. It's basically the same thing as our normal slope. You just find the f of x and subtract. So it's just like y sub 2 minus y sub 1 over x of 2 minus x of 1, but in function notation. So basically, that was the secant line that we did in pre-cal. Okay, but since we're trying to find the equation of the tangent line, we have limiting values of the secant line. So basically, it's like taking the limit. As the secant line here, the secant line gets closer and closer here, then we'll have the tangent line. So we're going to be taking limits. All right? And it's not that difficult. We're going to do one problem here. And then the next two videos, I'll do lots of practice problems and graphs. So we have the equation of a secant line. We know the slope of a secant, or the tangent line, and we're going to take the limit of this. So basically, we're going to put it in point-slope form. You're familiar with point-slope form. In this case, we're going to just use different notation. Instead of x and x of 1, we're going to use x and c, because it's some constant c. And we want this point here, the equation of the secant line that goes through this point for f of x equals x squared over 4. So I already drew it here, and we just want this equation of this line here. So basically all you do is we're going to use the limits, and because it only contains the one point, and I'm going to take the slope of the tangent line and find the slope of the tangent line by taking the limit as x approaches 1. All right, there's your 1 that you're looking at, this 1 right here. So we're going to get, the equation's going to be f of x minus f of 1, okay, that's your c portion, or over x minus 1. Now, that's going to be the limit as x approaches 1. F of x is 1 over 1/4 x squared, so x squared over 4. And minus, you plug in 1 in this equation here, and you get 1/4 all over x minus 1. Okay, now I'm going to rewrite this as x squared minus 1 over 4 over x minus 1. We're taking the limit as x approaches and gets closer and closer to this value c here. Okay, now I'm going to rewrite this on the next page as x squared minus 1 over 4 times x minus 1. Basically, we can just bring this 4 down here. Now, I'm going to factor, and we should be writing the limit here. The limit as x approaches 1. So we're going to get the limit as x approaches 1 of x minus 1 times x plus 1 over 4 times x minus 1. We're going to cancel these two and take the limit as x approaches 1 of x plus 1 over 4. And you're going to solve this algebraically and plug in the 1 here. And you're going to get 2/4, which equals 1/2. So when we have the x is 1, we're approaching the c part. So basically our c was 1, and then we have f of c. And when you plug in, when you take the limit, since we're talking about the tangent line, we're going to get 1/2. All right? No, this is 1/4. We already have this. They gave you that. I'm sorry. And this is the slope. And then you just fill it in. You're going to say y minus 1/4 equals 1/2 times x minus 1. Okay? And that's the equation in point slope form. You can see the point here. And then if you want to rewrite it in slope intercept form, we would move this over, the 1/4 over, plus 1/4. And that would end up being y equals 1/2 x minus 1/4. This part here, remember, that's just like saying negative 2/4 plus 1/4. Which gives you the negative 1/4. And that's all. The next video is going to be about a lot of different problems. And then we'll go quickly through those. And I'm going to do the next video mainly on equations with curves, because it's easier to see. And then on part 3, we're going to also talk about the equation of the tangent line to a line.